research review. So we've got the click that shouldn't have worked, RCE via clickjacking in Internet Explorer. I'm actually looking at this for a reason I'll get into, but this is by uh, Igor Saksakowski or Psych0tr1a, I don't know, but from PT Swarm. So the reason I'm interested in this article is because I actually have it like an escalated unreported bug with fellow bug bounty hunter on some application that has an HTML injection in what I think is the same context. And I poked at it a little bit, trying really stupid stuff to try to get at least local file read maybe or something, because it's I'm pretty sure it's supposed to be secure, but we'll get into this and find out. Author's note: this article describes vulnerabilities in ascending order of severity. If you want to skip straight to the most interesting part, feel free to read it from the bottom up. See, this is good for us because we get to build up to it, right? It's more exciting that way. Even though Internet Explorer officially reached its end of life in 2020, its core engine remains widely used in the form of the web browser control. This component is used in applications written in Visual Basic, .NET, and C#. True. Recently, I have discovered and documented several vulnerabilities in softwares using web browser. A notable example is my research titled "Winterize Vulnerable Trialware When Free Software Isn't Free," which details how an MITM attack could lead to remote code execution in one of the world's most popular file archivers. Yeah, believe it. While preparing this research, I tried to find information regarding the official status of the web browser control. Yeah, because I'm pretty sure that the underlying IE is supposed to be secure, and it gets patched with Windows updates, right? And surprisingly, no official documentation states that it is no longer supported or about to be deprecated. Furthermore, it appears that while I was working on this article, Microsoft restricted access to IE mode and Edge even further. This came in the response to the discovery of APT attacks using social engineering tactics. Great. The exploit Chakra on entry point abuse in August 2025, Edge team received credible intelligence that threat actors were leveraging basic social engineering techniques alongside unpatched zero-day exploits in IE JavaScript engine Chakra. Okay, so maybe there are unpatched. Who do I need to reach out to? And I don't even know if this bug still exists in this target we were looking at, because it was I can't remember how many months ago now. And it wasn't even a great bug, but it's we have script execution in the old IE via a browser. Who has... Do you think Chapman has them? I don't know. I don't know. The attacker would first convince the victim to navigate to an official-looking spoofed website, then use a flyout on the page to request the user to reload the page in Internet Explorer mode. The attacker would then leverage a Chakra, IE's JavaScript engine exploit to gain remote code execution. Finally, the attackers would use a second exploit to escalate their privileges out of the browser to gain full control of the victim's device. I might do some follow-up here. Because, it's not even a good bug, but it's just, if the HTML injection is still present and I can still get the script execution, it's I might as well get the door closed. And then it's when you collaborate with people, you like to find bugs and get bugs paid so that they're happy about spending that time. But I don't know, man. All right, useful information. I need to worry about this research and not about that lead. Before we dive into the research, let's break down some key terms that will appear frequently. This will help avoid any confusion when we analyze the vulnerabilities. ActiveX, a deprecated Microsoft framework that allows Internet Explorer to access APIs of third-party libraries installed on the operating system. A new ActiveX object can be instantiated using a CLS ID or a prog ID. CLS ID, class identifier, a 128-bit number serving a universally unique identifier for a specific software component or COM object. Prog ID, programmatic identifier, a human-readable text string used in Windows to identify COM objects or file associations. By the way, this is very helpful, useful information as somebody that does not like Windows and does not like all of these things. It's yeah, I've seen these words, but I've never had, fantastic explanations as to what exactly they are. Component object model, COM, a Microsoft technology that enables software components to interact independent of the programming language they are written in. Developers interact with an object through its interface without needing to understand its internal implementation. These are such funny definitions that are so write-up specific. 'Cause it's like, yeah, it's a lot more complicated than that. But if that's all we need to understand this write-up, that's good. Because I do not want the long answer. Because I know, you could have a whole set of articles on. Jeez, I don't like Windows. Mark of the web: a tag applied to the files downloaded from the internet. When you run such a file, Windows displays a security warning. You can check for this tag using the following PowerShell command. Yeah, that's a pretty cross-platform concept, and even beyond. Man, there's some bad stuff. Same origin policy: fundamental security mechanism in browsers that prevents a document or script loaded by one origin to interact with a resource from another origin. Yeah, I tried to break SOP briefly in there, and I just tried the dumbest things, and it's oh man, it didn't work. NTLM, NT-LAN manager, Windows authentication mechanism, an NTLM leak occurs when an attacker captures encrypted authentication requests for subsequent GPU-based brute forcing. Yeah, I think a lot of NTLM leaking is harder on Windows 11 with the default settings for oh man, I'm not just gonna talk to that random share. It's come on man, send me everything you know about yourself. Security zones: set of rules and restrictions in Internet Explorer assigned to a resource based on its origin. ActiveX, how it works. How long of an article is this? It's a lot of pictures. We'll see what we can get through. Here we go. ActiveX, how it works. The first thing we need to discuss is Microsoft's legacy ActiveX framework. This framework was used to create software components that ran in the Windows environment, including in Internet Explorer. Due to security risks and obsolescence, its use is highly discouraged. However, it still functions within the web browser component and IE itself. Let's look at an example of using CLSID that this identifier is stored in the registry at HKey local machine software Microsoft Active Setup installed components and corresponds to Windows Media Player. Using this code, we can play a media file named test.mp3 via ActiveX. No. There's another way to instantiate an ActiveX object via prog-id. In the below example, we access Windows Media Player through string wmplayer.ocx, creating an instance of the object using JavaScript. Jeez, man, that's I'm glad nobody's doing anything like this anymore, browser-wise. Mark of the web. Now let's look at security markers. Imagine I have two HTML files in my downloads folder. I created the first in Notepad local file. The second one was downloaded from the internet. Let's look at their mark of the web tabs. Yeah, so the local one doesn't have anything. The downloaded one has. Oh, I forgot. Man, why they got zone details? That's so sad. But yeah. The results are as follows: local file, no tag, download from the internet, tagged with mark of the web, security zone 3, zone ID equals 3. Oh, I thought it said 2. Wow. Security zones. Since we mentioned zone ID equals 3, let's take a closer look at how security zones actually work. Internet Explorer uses a zone-based security model where each zone has a specific privilege level and component access rights. This is actually really good to know about, because I feel like when I want to understand the injection context, it's which zone am I operating in? And it's I think it might be zone 0. I'm not sure. 0, my computer file URI is 1. Local internet zone. Does it also include the class B private ranges? Probably, but maybe they haven't. All right, yeah. 2, trusted site zones configurable by the user. Yeah. 3, internet zone internet.site. 4, restricted zones. That'd be a cool domain down. Configurable by the user. Yeah. All right. So wait, do you need to do that? Okay. During my experiments, I discovered that the browser has 2 special zones that are difficult to place in the list above localhost and file SMB. Characteristics of localhost: has access to numerous ActiveX components. Really? Has access to remote SMB servers by default if they are in the same zone. Characteristics of file SMB: uses the file URL scheme, leads to NTLM leak by design. Nice. Does not have direct access to local files. Let's check the privileges of a page hosted on the local host. I need to pause recording and send this along because alright, I got way too distracted, but right. So yeah, so file SMB. So NTLM leak by design is actually interesting. That's, it does not have direct access to local files. Okay. Let's check if privileges of a page hosted on localhost differ from those on an internet page. Yeah, that's very interesting. Well, and also, can we load files from file SMB, and then can we read local files somehow magically with some trick? Let's see. To do this, we'll try opening a file from an SMB server by clicking the link. Based on the test results, we have the following. You can open files from an SMB server, file SMB, using a page hosted at localhost. You cannot download files from SMB server. Interesting. It appears the localhost has elevated privilege compared to the standard internet or intranet sites. Based on this, we can build a hierarchy of zones based on their privilege. So, internet zone, boring. So yeah, local files definitely the most interesting. wscript.show. Do they really have that? Interesting. Yeah. Okay. A file localhost. See, that's cool. Backstory, part 1, access to local files. Nice. That's what I was trying to do. So I could have probably would have liked that bug. A few years ago, I started hunting for insufficient HTML sanitization in desktop applications that could be exploited for cross-site scripting. My goal is to perform remote code execution or find something interesting or unusual by executing arbitrary scripts within the application. I installed a bunch of potential vulnerable apps and kept a running log of my findings in a spreadsheet. Today we will break down one of those findings. Initially I dismissed this particular case because at first glance it seemed difficult to escalate to RCE. Ha 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 ha! I've totally never been there. That's totally not the whole premise of this, me looking at this. My primary focus was finding instances where JavaScript is executed under the file origin. Turns out, yeah, that's a lot to ask for instead of a worse zone. Later I revised my notes, tested my hypothesis thoroughly, and realized that the issue I had accidentally stumbled upon wasn't rooted in the application itself or its configuration, but in Internet Explorer itself. Nice. Here we go. One of these notes, a random result from manual fuzzing. When I executed alert location in the desktop app, the pop-up displayed localhost. All standard methods for opening new windows were disabled except for show modal dialog. I tried opening an HTML page from a test SMB server, and it loaded successfully. My next step was to execute HTML code on the SMB server. Later I discovered that the SMB server wasn't even necessary. The exact same behavior could be reproduced on a local web application by specifying the base href file tag. Ah, man. Here's the code that would be hosted on the SMB server. So it's an HTML file, it's got an iframe, it's got a script for the named frame, or naming the frame. Why? Interesting that it does it that way. And then it's opening to that frame another file that's being loaded from the weird localhost based read. Okay, that's equivalent. That's weird. Okay. And then this isn't. Is this new line supposed to be present? This doesn't parse as valid JavaScript. Sorry, this doesn't do what I'm sorry, I can't read this. In the example, we open 2 links in a row. If you open the first link, pause, and then open the second, a pop-up will appear before the second link executes, stating that the URL is invalid or malformed. However, if you open the links in rapid succession, the pop-up doesn't have time to appear. During testing, I manually tested various links. One of them triggered that exact pop-up, but after I closed it, links that were not supposed to open suddenly did. Nice. I managed to reproduce this behavior and eventually found a way to bypass the pop-up entirely, minimizing user interaction. Ultimately, this behavior allows an attacker to open local HTML files. Nice. Simply put, we found a portal from the internet to local files using HTTP localhost as a proxy. That's very interesting. Important limitation: to exploit this feature, an attacker must first find a way to drop an HTML file onto the victim's computer. Surely you don't have a gadget that lets you do that. For example, via previous attack stages or social engineering, and the victim must be running on a web application vulnerable to XSS. Today, having a web application constantly running at localhost is not uncommon. This could be an email client, development environment, LampSamp, builds, Electron-based software like uTorrent. I've been really trying to not comment on No, I'm not. I'm just staying out of trouble. Part 2: downloading arbitrary files without mark of the web. The most logical next step would be to try forcing the browser to download a malicious file, right? Yeah. However, Internet Explorer prevents files from being saved to disk without user interaction. It always requires explicit confirmation, but what if it didn't? It took me 8 months of research to find the easiest bypass. It turns out Internet Explorer can open a page in Microsoft Edge, okay, without any user interaction by using a link formatted as Microsoft Edge HTTP site. Because modern Edge is Chromium-based, it can automatically save files to downloads without any questions. I like that. That's a good trick. Fortunately, I cannot disclose the details of the vulnerable application used in this example, but the screenshot above shows an ActiveX security warning. This warning appears when a local file attempts to instantiate a highly insecure COM object WScript shell. I'm showing the final stage of the attack where the malicious WScript shell is attempting to instantiate and is requesting user permission. Not all COM objects request such permissions, only those that are well known and lead to command execution, data leaks, or other unsafe events. When testing this behavior, I used localhost for the page that initiated the file download. When the file was saved and executed, I achieved a one-click RCE by clicking yes in the warning. Don't click yes. Is this where the clickjacking comes in? However, when I repeated the test under more realistic conditions using attacker instead of localhost, RCE failed. Interesting. After a few experiments, I figured out why. When downloaded via localhost, the file saved without the mark of the web tab, without this tag. Windows does not block dangerous operations. Jeez. In this specific HTML scenario, the ActiveX warning becomes the only barrier preventing total system compromise. This deviates slightly from standard IE behavior and looks like a misconfiguration. Normally when IE opens a local file, it displays an additional security prompt asking for permission to run JavaScript from a local file. Yeah, there's a lot of stuff to look at here. It's like if we can migrate to a higher privilege zone in our bug, then we can maybe do some stuff. So that'd actually be like a good goal, is to like, can I figure out a way to get it navigated? Can I get local file dumped and can I navigate to it? Bug 1, auto download and auto execution of local files, building the attack chain. So I'm guessing a lot of the like core vulnerabilities here are fixed in latest Windows. Although I wonder, Now we can attempt to download an HTML file without the mark of the web tag and execute it immediately. Local files without mark of the web allow us to use a very old technique from the 2000s, remote code execution via WScript shell COM object. Nice. Logic behind RCE via WScript shell, a malicious page opens localhost, hosting an application vulnerable to XSS, using it as Explorer. XSS payload at localhost launches an edge window pointing to its own location. Using the edge window, XSS payload at localhost forces exploit.html to download into downloads without the mark of the web tab. Okay, so even like modern Chromium or Edge auto downloads use that same rule for it came from localhost. We don't mark of the web it. The edge window can then be closed automatically. The IE window redirects the XSS from localhost to the locally saved exploit, leveraging the unclassified vulnerability described earlier. I wonder if blobs are supported and how they behave in this context. It's just like my random thought here. It's like, yeah, redirects the XSS from localhost to the locally saved exploit, so you can navigate to a file URI. Yes. Okay. Nice. To achieve arbitrary code execution RCE in Internet Explorer, only 2 clicks are required. Do we need a window.open to open the file URI? Or is it abusing? Maybe this got fixed. The final JavaScript code, yeah, okay, 2 clicks on security prompts. Yeah, that's not great. Bug 2, this is great, we're on bug number 1. We're going to be working our way to some really cool stuff here. Not that this isn't a great dance. This is very interesting. But, yeah, bug 2, NTLM token leak from any website. Okay, that's, jeez. While searching for ways to download files, I tested numerous built-in IE features, which led me to discover several other flaws. Found one of them while investigating what else JavaScript could do on localhost. If you try to open .css from localhost, it will not open in Internet Explorer. It will open in a new Notepad.exe process. Really? Example of can we have like a decompile the thing and let's look at it, dude. Like, why is it behaving this way, and what code causes it to behave this way? Example of HTML code with a link to CSS file that opens Notepad when clicked. Internet Explorer first downloads the file to a temporary folder with a random generated name, and then the browser starts a new Notepad process to open it using a simple fuzzer. I want to see the decompiled code flow. Like, what if there's some really weird stuff going on there, man? Like, instead of dumb fuzzing. It opened every registered file extension on my Windows system one by one. I managed to launch various processes. The table below shows examples of file extensions and the applications they launch. Nice. That's very cool. Acrobat, jeez. Visio, lol. Interesting, okay. Most peculiar. Windows Form, click once, XAML, XBAP, VSTO, XML files containing the URL of a manifest file and binary data for execution. Windows Media, WMD, WMZ, zip archive, settings and skins. Ooh. Wax, WMX, XML playlists. Let's focus on the playlist since Windows Media Player can be launched from IE via ActiveX from any site. We can test more. Does this require an approval prompt? I don't know. We can test more supported playlist formats by launching the player first and feeding it the necessary files. I conducted further tests using ActiveX object and other playlist extensions, yielding more results than redirecting from localhost. So this does require a click on the link, though. Column 1, the tested extension. Column 2, the result of opening from localhost. Column 3, the result of launching files via ActiveX. Okay. So Wax, WMX, yes. No, no, no. Yes, yes, yes. Why are playlists interesting? They can contain URLs of files on a remote SMB server, automatically exposing NTLM hashes during playback. Yeah, that's what I was kind of hoping before we migrate to some other context that trusts those. Okay, that's interesting. Wow. Okay. Yeah, that rules. So that gets opened in Windows Media Player, and it's like, yeah, let me go grab that. And it's like, oh man, let me go talk to that guy. Not a bug, but a feature. Let us return to Windows Form and click once file extensions. I stumbled upon these files again while reviewing Internet Explorer security zones. Yeah, I don't know about those. In this security zone setting, there are options such as loose XAML. Is it XAML? I don't know, man. I really like calling it XAML because that's funny, and XAML browser applications. By default, for the local internet and my computer zones, these are set to enable or prompt. Which one? I guess each one. This means that files with specific extensions can be executed with minimal user interaction, sometimes with no notification at all, sometimes requiring just one additional click. Which extensions fall into this category? You can open files from the following extensions from localhost and from local files. Okay. Let us analyze these extensions. Extensible Application Markup Language is an XML-based markup language used to define user interfaces in .NET applications. When opened in Internet Explorer, it does not trigger security errors or confirmation pop-ups. XML allows the instantiation of arbitrary classes, but with serious limitations. Only static classes and methods are available, and the sandbox strictly restricts access to system functions. That sounds so scopy, and that sounds like C# .NET deserialization hell. What happens when the file is opened in Internet Explorer? XML, NS, sys, declaration, and XAML. I don't like the letter X. We should just get rid of it. The references the system namespace from the .NET assembly. Object data provider is created and calls the static method of concat. The system string class with the arguments, blah, blah, blah. The result is that. Next, the second object data provider is created, the senso deserialization. It takes the result of the first operation and calls the index of method. Okay, nice. So yeah, we're able to do these like change static calls. 3 values are displayed on the screen: length of the concatenated string, the string itself, and the result of the index of call. Attempt to escape the sandbox. Yeah, this sounds... Oh man, I'm glad we're going through this. This is actually a really cool write-up. I feel like people are sleeping on this because I just love how he's just like, how are we gonna hack this? However, like, we are gonna use everything. We're gonna if we find ourselves in some stupid context that shouldn't even exist anymore, it's like, let's go, we're gonna party in it. Like, I don't care if this requires a bunch of Windows bugs and old Windows components to pop whatever target he's trying to pop, these old desktop apps. So that rules. Attempts to escape the sandbox. I tested the possibility of performing more dangerous actions via XAML. The results were predictable, trying really like something normal and you're supposed to do, or something obviously like, how do I sandbox this? I should block system, network, and file I/O calls. XAML operates in strict isolation, a .NET sandbox from which dangerous system functions cannot be called without additional permissions. Testing various ways to load XAML. To understand where and how XAML files can be launched, I created 2 HTML files with different opening methods, which will open from localhost /xaml.html file SMBX, as well as local file. First method is opening an HTML file and then a .xaml from the same location. So this is like what, framing it, yeah, and then a link to open it. The second method is opening an HTML file from from SMB server, testing opening via origin chains. Okay, so yep, so those are all SMB based. Explanation of the elements in each test. The first iframe shows a directory listing like Windows Explorer. If you open a folder via file scheme, in Explorer interface automatically appears when you double click a file to launch it. The second iframe attempts to automatically load and display the XML file. Okay, nice. The A element is designed to launch the file by clicking on it. So let's see. I'm most interested in iframe with file. So from localhost, yes. From file SMB, no. From file, yes. Okay. SMB test, or okay. So now that's no fun. Interesting. And then where's the click one? Is there an anchor tag one? Oh, here we go. So, this behaves the same way. That's good. I like this one the most, right? This is like objectively the best one, where it's just like, it's just running, have fun. With like no clicking, no required interaction. It's like the page loaded and now we're in this rendering context. Observation when testing different launch methods from different origins. Directory listing via the HTTP protocol does not work. It does not trigger the required functionality. Double clicking on the frame of the directory listing launches Edge instead of IE. Launching XAML from file SMB is completely disabled, or rather broken, due to IE being disabled and all links being redirected to open an Edge. Conclusion and on.xaml. It allows us to run .NET classes, but inherits the security context from the XML document with strict. I can't read anymore. Which strictly limits its capabilities. It is the only format in its group that shows absolutely no security prompts upon launch. Yeah, this is very interesting if you could actually take apart the sandbox and find an escape. Other extensions, .vsto, application, xbap, when tagged with mark of the web, do not show classic security prompts, but have their own notifications which make them less useful. Okay. The sandbox can be bypassed by using undocumented features of available classes, finding a chain that does not inherit the context, or exploiting memory-related .NET vulnerabilities. That would suck. Yeah. That would be interesting. That would be crazy. That would just be total escape. But in my mind, it's like, you just have to be more clever than the sandbox, or wait for them to have added stuff that is actually does dangerous native stuff and gives you some like file IO primitives or something. Or I mean, even like honestly, if you can just get like a drive-by NTLM hash leak, that'd be cool. It's like, yep, it ran the iframe, it rendered the content, it called some classes, and one of those actually did something that automatically would connect to SMB paths, and it's like, oh man. Alright, whatever. So, Visual Studio tools for Office, VSTO. VSTO are plugins for Microsoft Office applications. A compiled VSTO file is an XML document containing a digital signature and a link to the main manifest.dll.manifest. Example, a source code for VSTO plugin that launches calc.exe. Yeah, I don't know about these because I don't know about Windows. And this is definitely I mean, actually, I think I've heard of these, like, because it's so pen testery. It's like oh yeah, you were blocking execution from like my PowerShell script. Well, you're getting VSTO'd, and it's like, what, dude, go away. All right, yeah. So this is really cool. Yeah, that you're able to get code execution. I mean, man. Oh man, yeah, they should not have. I'm glad we're not doing things like this anymore, right, guys? Like, modern applications aren't being built with crazy things like this, right? Compiling this code results in a VSTO plugin that when Excel is launched attempts to execute the calc.exe command. Yeah, that's really cool. Oh man, you have to hit install, that sucks. Oh man, it's a bunch of security prompts. As I mentioned earlier, the group of extensions, VSTO application, xbap. I love these GIFs, by the way. This is so good. It's like, oh wow, I can actually see what's going on now. And also I love the aesthetic. But alright, yeah, so as I mentioned earlier, yeah, does not show their classic Windows security alerts when running like when running an exe from the internet with Mark of the Web applied, but they do have their own dialog box, publisher warning, request for access to unsafe functions, installation request. So I guess these are all no's that you can try to bypass. File location information without Mark of the Web, the file is considered local. An installed VSTO plugin can be removed via the standard apps and features. Oh wow. Auto starting via test2 from local files triggers a security prompt without an additional click. Okay. When test1 from localhost opens a folder from on the SMB server and VSTO file is launched with a double click, there are different warnings. Okay. This tells us that localhost file SMB chain is less privileged than file SMB, as it displays an additional pop-up window. However, launching directly with localhost does not have the restrictions that file has. Conclusions for VSTO: it allows us to inject backdoors into Office applications. It requires complex social engineering techniques to trick the victim into clicking the security pop-ups. True. It can be launched from a remote SMB server, but loading it via localhost file SMB chain requires an extra click for confirmation. Okay. Click once. Applications. Unlike VSTO plugins, the click once technology allows us to create, which is so much newer than VSTO, right? Allows us to create fully fledged console and windowed applications that run in isolation rather than Office applications. So you've got some C# looking code that, after compilation and publishing via click once, we obtain a file with the .application extension, which attempts to install and execute the application. Okay, yeah, so nice. Note, auto starting via test2 iframe with the file triggers a security window requiring confirmation just like with VSTO. Opening via double click from the file SMB folder works perfectly from both the start pages. Interesting. So if you double click it in the file view. Okay. XBAP, XAML browser applications. This type of applications run directly in the browser, although technically it is a separate process. XBAPs are .NET applications that run in the browser sandbox. What? 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 But can execute arbitrary code if granted the appropriate permissions. Security prompts are similar to VSTO in application, except that the installation is now considered trusted. Okay. Observations when testing different launch methods. Auto starting via test2 from file shows a security prompt like VSTO. Launching via double clicks and file SMB folder is broken. Edge opens instead of IE. Great. Conclusions on XBAP. It allows us to execute commands after Alright, my mic died. I hope it wasn't too bad. Whatever. What are we? 32? Okay. Bonus, Microsoft Edge. Unlike Internet Explorer, .application and .vs2 extensions, files with .application and .vs2, I need to maybe take a break. This is going too long and I can't read anymore. Can be launched from a website in Microsoft Edge, not just from localhost. However, an additional click is now introduced, a confirmation window similar to one that appears when launching a third-party process via URL scheme in Chromium. Yeah, I know about that. Let's talk about things I know about. For example, when launching calculator URL. Okay. So, interesting. So it's just a lot of clicks, though. This makes an attack via Microsoft Edge slightly less attractive, but still possible with clever social engineering. I'm actually going to pause and maybe get some water, but we've made some good progress here, and we're putting together some interesting pieces that'll be, especially if we get some clickjacking in play that somehow allows us to work around all of these click requirements. It's still, not great. I would love to see just silent RCE, but it's interesting. Alright, not a bug, but a feature for UXSS. Some browsers support the MHTML, MyHTML web archive format, and Internet Explorer is no exception. Moreover, IE has its own URL scheme for format MHTML. The syntax of MyHTML web archive is similar to multi-part form data HTTP request and often uses similar content types, multi-part related or multi-part mixed. IE allows us to create a web archive from any project, from any page. I thought taking a small break would let me read. From any page with a simple Control-S keyboard shortcut. I discovered that a local .mht file that lacks a Mark of the Web tag and includes two specific headers Oh, what? Headers. Header. I didn't. Those can have header. No. I guess kind of like a meta tag. Oh man, that's so. Can lead to a same origin SOP bypass. This file allows us to emulate an arbitrary origin and execute JavaScript on any site. What are these specific headers? Content location. What? Which, I guess that's the origin. This header indicates the URL from which a specific part of the page was saved. Seems this header overwrites the origin of the contained HTML. What? Content ID. This header creates a virtual ID that can be used to load a specific part of a page. What? This is... The logic here is the same as in bug 1, but instead of loading a .html file, we now need a .mht file. Edge does not allow automatic loading of .mht files, considering this extension unsafe, but we can still load files manually with a single click anywhere on the page. Localhost XSS to UXSS proof. So we have that funny behavior, some named frame that there we go. Calls functions. So okay, it's trying to read the HTML. I see. Okay. How it works. The drop HTML function contains a variable with the exploit source code. This is the MHT file. There we go. This is miserable. We don't have multi-line strings. So that, okay. The content location, that's interesting. The main part of the exploit, content location, MSN1, loads the second part of the archive via the iframe source. Part of the content location and content ID loads a new iframe. The URL of the frame /a111 is not specified in the web archive, which leads to loading the real content of MSN at the specified path. Accessing the frame via JavaScript is possible because content location, the spoofed origin, and the target frame's origin match. SOP considers them to be same origin. Great. Sometimes the exploit requires a reload. This behavior is implemented via the tag meta, okay, which reloads the page every 2 seconds. Interesting. UXSS via .mht summary. It requires one click in the Edge window to trigger the download of an unsafe file type. It allows us to execute JavaScript on an arbitrary site. Universal XSS. It requires an already installed local web application vulnerable to XSS. Yeah. Interesting. That's can it do file URIs? Not a bug, but a feature. Recall that using iframe, we can not only automatically open files, but also retrieve the listing of local files or folders on a remote SMB server. Does that work from non-file URIs top level? This functionality is very similar to explorer.exe and allows us to copy, delete, and execute files using the mouse. Wait, yeah, you can just frame a file URI. RCE via clickjacking type 1. Using the HTML tag iframe, you can open a folder or files that are displayed as a folder. Okay. But that's top level file URI. Can we do that from... okay. A local folder or a folder in an SMB server or zip archive, which .search.ms file saves search, not exactly a folder, but has similar functionality. Logic behind the new chain, so we've got attacker.com. I guess, is that like a... Alright, malicious page opens HTTP localhost, hosting an application vulnerable to XSS. Okay, so yeah, that's attacker.com. XSS payload at localhost launches an Edge window pointing to its location, which causes a download. Using Edge, the Edge window, the XSS payload saves files, proxy HTML, and exploit.zip to downloads without the mark of the web tag, because it's going through localhost. The obtained files inherit the mark of the web settings from their archive. Internet Explorer window redirects the page from localhost to the locally saved HTML file using the vulnerability from bug 1. Okay, so you're not supposed to be able to do that, but you can go from localhost to file URI that way. Loaded HTML page opens the zip file containing the exploit using iframe. The user needs to double click on the file name inside the iframe to execute it. Okay, wow, that's pretty cool. I use JavaScript to set the iframe element size to 5x5 pixel. Yeah, I configured it. Yeah, so that's always under the cursor. Yeah, I've written code like this. This allows clicks to be made anywhere on the page while actually hitting elements inside the invisible frame. Yeah, I've had like a game that like you click on the squares, but sometimes the clicks don't go through because you're hitting an iframe that's following your mouse. What happens in the code, an invisible div with absolute positioning is created when the mouse move. The div follows the cursor. Inside the div is an iframe containing a folder or a zip archive, and I'm guessing it's like zoomed and scrolled by default so that you're hitting the target. When the user clicks anywhere on the page, the click actually hits inside the invisible iframe, and if there was a file there, it's executed. Yeah, that's really cool. This exploit can be used. Conclusion for this chain: this exploit uses a base64 representation of a zip file containing the malicious file. When decoded, it results in an archive containing the clickjacking file. Arbitrary command execution without any security prompts requires the ability to conduct an XSS attack on an already installed vulnerable web application on the local host. Yeah. Requires a double mouse click anywhere on the page to execute the file. 2. RCE via clickjacking type 2. Using the built-in debugger console, I inspected the code of the iframe element, displaying the file list. Unexpectedly, I discovered that instead of a regular HTML document, inside there is an ActiveX object with CLS ID, prog ID, shell. Okay, interesting. I was even more surprised when I decided to edit the object. Many different parameters became visible. Oh, wow. The param name equals single click parameter immediately caught my attention. I assumed this setting would allow me to launch files with just one click instead of two. Yeah, that's really cool. However, initial tests showed that reducing the number of clicks to one was not that simple. When launching an ActiveX component from a local file, an alert appears requiring a separate configuration, so you can't just load the Explorer ActiveX component with arbitrary properties instead of doing it this way without more prompts. That is really cool. Conclusion: 2 clicks are required to complete RCE, but following a completely different scenario. The first click enables blocked active content, the second click executes the file. Theoretically, if the security prompt is bypassed, user interaction could reduce to a single click. Yeah, so I like the other one better, but that's really cool. RCE via drag and drop. Now we're getting to run while in here. Besides clicking on files, users can drag files between windows. I'm sure there's so many problems there in old IE. Another discovery of mine: if you drag any file onto a specifically crafted .link shortcut file, the program launches, but the mark of the web check is not performed. And the security confirmation dialog box, like the one in the example, does not appear. For example, the security prompt during a normal launch of .link with the mark of the web tag, it looks like yeah. So chain logic, you've got malicious page opens localhost, hosting an application vulnerable to XSS. XSS launches an edge window with the address of its location. XSS window saves exploit.zip to downloads with a mark of the web tag. Okay, so it's coming from attacker. Inside the archive, there's a specially crafted link file. Internet Explorer redirects from localhost to the locally saved zip file using the vulnerability from bug 1, so I'm guessing that's the base URI. The user needs to drag any file, for example, from the desktop onto .link inside the zip archive, displayed in the browser via iframe as a result of the command. Okay, so you could do something like the funny Renwell pool game, maybe. Actually, that was for like middle mouse drag. That one was really cool. Example of creating a malicious link file. The target field contains the command executed upon launch. Yeah, nice. So launching CMD with /c and then arbitrary commands. So I like that. So drag it, and let's see what it looks like. There we go. Drag one square onto the other. Yep, nice. It's not quite a pool game, but hell yeah. Code execution. Let's go. That rules. Conclusion for this chain: it does not require clicking on security prompts. Yeah, that's really good. Mark of the web protection mechanism can be bypassed. That's good. 4. RCE via drag and drop type 2. Okay. I can only handle so much drag and drop browser exploitation. Windows has several built-in file extensions that handle object drag and drop. .map imail, .mydocs, .desklink, .zfs send to target. Okay, so opens Outlook and uses the dragged file as an attachment. What? Creates a shortcut to the dragged file in document folder. Creates a shortcut to the dragged file on desktop. Creates an archive containing the dragged file. If you drag any file onto a file with the .desklink extension, for example in an Explorer window or a browser iframe, a .link shortcut pointing to the dragged file will be created on the desktop. but when you drag a .link file to the .desc link, it will just place a copy of .link on the desktop. At the same time, you can set an arbitrary icon and name, for example, this PC with a computer icon or secret photos. Okay, that's cool, an interesting way to write to the desktop, and then, like, they'll click on it. Like, what is this on my desktop? I gotta click on it. The malicious page opens at, I wonder if you could get a symlink written, whatever. Malicious page opens at localhost, yeah, using Edge to download it. Edge window saves the files, yep. With a mark of the web tag. Internet Explorer redirects the page from localhost to the saved file using the bug. HTML file displays the contents of the zip archive. User drags the link onto the zip archive, it writes it to desktop. Yeah, that's really cool. Why am I showing this example? With a slight modification, it also leads to a mark of the web bypass. Initially, I tested this technique using a local SMB server. That's when I noticed when copying files from a zip archive, but not from a zip archive, but directly from an SMB server by dragging them onto .desc link. No additional confirmations appeared before launching these files from the desktop. Presumably, this behavior occurs because the file inside a zip archive inherits mark of the web from the archive, but when copying from an SMB server, mark of the web is only applied after the copy is complete. Yeah, that's weird. The non-standard copying method, drag and drop, disrupts this logic, and mark of the web is not set. Wow. Conclusion for this technique: it allows us to write malicious shortcuts to the desktop with an arbitrary icon and name. It does not require clicking through security prompts. It allows us to bypass mark of the web when copying a .link from an SMB server. It requires additional interaction launching the file from the desktop, which looks quite realistic given a plausible icon and name. Final remarks. The main issue that would allow attackers to open a local file using JavaScript at HTTP localhost was fixed in September 2024 while I was looking for other vulnerabilities to build chains. In my case, the research started with an XSS attack and a desktop application that allowed attackers to execute JavaScript from localhost, the origin. I also discovered the possibility of conducting XSS attacks in other desktop applications. In these cases, the injected JavaScript code was executed from file, the origin. This condition means that some of the payloads described in the article, which are considered features, still allow threat actors to escalate XSS attacks in vulnerable applications to RCE. I want this. So I actually probably have to look into this. I had better things to do, like higher ROI things to do, but at this point I might just be like nerd sniped into dealing with this, because with all this fresh in my mind, I want to go look back at that target at least for a couple hours, and see if I can like figure out what zone I'm in and if I can get to a lower zone and pop it, and how some of these tricks, I want to try some deviations on some of these tricks. Right, so research review points, and not just me being excited. Okay, so how does this generally apply to bug bounty? I really like that, like, we're gonna hack these desktop apps. Oh no, we're in some secure node. I mean, if to pop this, you'd need a bug in IE context, and it's like, oh, not only are we looking for bugs in IE to get this to pop, we're gonna look for bugs in like, or bad behaviors in like Windows Media Player, and it's like, I love that. That's just going, or we're gonna look for .NET Sandbox escapes from these static calls, and they're just going full chain rules and just like willing to just be like whatever it takes to pop RC in the target app, even if it's a little gnarly, and like, maybe, obviously they shouldn't have that HTML injection in that context, but yeah, the RCE piece of it is a little Microsoft's fault. I love it. Why did this work? I would like to have seen some deeper dives here, to be honest, into like especially like this fuzzing. Like, that's nice, but I want to see disassembly of IE, and like, why does it behave this way, and like especially the base trick. It's like, what else is going on in there, and how is the code flowing in the browser side for some of these, and what are the patches actually good, or are they very naive, and are there other variants that like are really obvious if you look at how the implementation actually works. Further research, what I just said. I have further research I want to do here. I'm going to go do it. I'm not going to say too much. I've already said plenty of interesting ideas. I'm curious how blob URIs work. But there's a lot of interesting behaviors here that there's just so much room for, like, well, what if we did this instead? I'm actually curious. I wonder how some certain SVG behaviors work. Rating. What do I rate this? I rate this zone 0 out of 10, which isn't a 0 out of 10, it's a zone 0 out of 10, which is like where I want to be. And then conclusion. Very cool research. Definitely a lot of things I want to follow up on, and a lot of... I'm curious, I would be interested to know, like, these vulns that were reported, they had, like, links. Were they reported, like, through MSRC? Did MSRC pay for these? What did the bounties look like? How much does MSRC pay for... Oh, man, I gotta, like, log in. Yeah, maybe maybe it says the payment on them. I don't know how MSRC works because, I haven't reported anything through them, but I kind of want to hack Azure, but I'm not going to do that right now. This is very interesting, really good write-up, definitely learned a lot, and I've got a lot of things I want to play with, so thanks for watching.